instead of putting a diver in the water where a diver would be at risk. We started using machines and robotics to take that risk. They are cost effective and they are also very safe. Because it's a robot, there is nobody going inside the vehicle, which means I sit on a ship and the vehicle is attached to the ship with an umbilical cable or an extension cord. So I can sit on the ship and put my vehicle down 1,000 meters or 2,000 meters, and I'm basically high and dry, and there's no intrinsic risk on me for going down. What this vehicle can do is it can dive into the depths of the Monterey Submarine Canyon that we have just off the coast here. It is a very unique place. We have a deep water channel that comes very close to the shoreline here. It's the deepest water close to any continental landmass in the world. So it allows us to really see some sea life that nobody's ever seen before. I work out on the bay on a 110-foot vessel called the Point Lobos, operating with Ventana. This is the control room underneath the bow of the Point Lobos. There's about 8 consoles which control all of the vehicular functions. This is a flexible cable that goes to the vehicle. There's about 1,150 meters of cable here. So it allows us to send information to the vehicle to tell it what to do. This is where the control commands for the vehicle functions come in, and it's basically the brains of the vehicle. This is the touch screen display. I can touch the screen and bring up different display menus. These allow me to turn on and off the components of the vehicle, like the lights, the cameras. This is our main Sony camera that we use to get all of our high-quality images with. And this is all the camera control. This gives us all of the video images. And this is a graphic display that allows us to see where the camera is. This is a collection device for capturing animals. We open the doors, drive this over top of the animal, and then close the doors. Business end of the suction sampler. This is where we slurp up animals, and this hose runs all the way back to this canister back here for us to put animals in. And they are all controlled from this unit as well. This console is where the chief scientist would sit. This is where the scientists have a display of a number of different cameras that shows us what we're recording and what is being sucked into the suction samplers. This is our navigation integration system. This allows us to know where the ship is, where the ROV is, and then it logs that information. This is the sonar up here. This gives us an electronic image. It's not a real picture, but it's sort of a generated picture from sound. This sonar allows me to see 100 meters out into the water so that I can navigate up through tight spaces without worry of entanglement. This is a peripheral camera, and we use these sort of like side mirrors so we can see along beside us so we don't drive the vehicle into canyon walls and things like that. This is a hydrophone. It's like a microphone. And if we turn off the vehicle hydraulics, we can hear underwater. This is the pilot's control station. This consists of a joystick which controls the thrusters. This vehicle has 6 thrusters, so you can drive it somewhat like a helicopter underwater. The buttons on the top of the joystick control the camera pan and tilt. This unit here is what we call a manipulator, master arm. We have a slave arm on the vehicle, which is a similar model to this. What this means is that this manipulator is an extension of my body, and I can reach out, pick up samples, put them in the sample drawer, and bring them back to the surface. Well, the whole vehicle system, it's probably running on the order of $1.5 to $2 million. It's like being paid to come play every day with a very high-tech video game. The only problem that you have with a video game such as this is if you have a problem, it's not a quarter that you've lost.